Okay, so for question number 4, we have solid table salt reacting with concentrated sulfuric acid. So we have our reactants for our chemical equation. We have table salt. We know that it has a formula of NaCl, and the problem tells us that it is in the solid phase. We then have concentrated sulfuric acid, and we know that the chemical formula for it is H2SO4. And because it is an acid, we know that it has an aqueous phase. So now we need to predict our products. And like we've been doing in the previous 3 examples, prior to predicting our products, we go through and identify what the charges are in our compounds. So for sodium, we know that it's an ionic compound, and sodium has a +1 charge, while chlorine has a -1 charge. In terms of the H2SO4, we know that sulfate, a polyatomic ion, has a -2 charge, and the hydrogen, each of them have a +1 charge. So in order to predict what our products are going to be, we need to do the crisscross method, where we take our cations and we switch them with the anions in the alternate compound. So we have cation 1 pairing now with anion number 2. So we have cation 1, anion number 2. So we have sodium, it has a +1 charge, pairing with sulfate, which has a -2 charge. We want to make sure that we properly balance our formula, so we do an additional crisscross where we take our number, and this now becomes our new subscript. So we would have Na2 and then SO4 1. And again, remember that when we have 1 as a subscript, we omit it because it is understood to be there, so this then becomes Na2SO4, or sodium sulfate. So we've predicted one of our products. We have Na2SO4, and if we double check to make sure that this is equal to 0, we have 2 sodiums, and they have a +1 charge. We have 1 sulfate, and it has a -2 charge, and if we go through and do that math, we see that it does indeed equal to 0. So we know we balanced our chemical formula correctly. The last thing that we have to be able to do is identify the phase of sodium sulfate. And if we look at our solubility rules, we see that sulfate is soluble with sodium when it is paired with it. So it gets an aqueous phase designation. Now, if we look at what is remaining, we want to pair cation number 2 with anion number 1. So if we look at that, we see cation number 2 is a hydrogen. And again, notice how I'm not taking the subscript for the hydrogen. I'm not taking H2. Remember, when you have polyatomic ions, you take the subscripts with you, which is why I took SO4. When you have just regular elements, you do not take the subscript. So this would just be H instead of H2. So H has a +1 charge, and it is being paired with Cl-. So, and this has a -1 charge. So again, we cross just the number, and we have H1, Cl1, which you know then becomes HCl. So we have formed HCl, and in this particular case, HCl is actually going to be in the gaseous phase. If you look at your introductory reading, you'll see that this gas is going to form. Now, the last thing that we have to do is we have to balance our chemical equation. So if we go through and look, we see that the sodiums are not balanced, so we have to make sure that we balance those. And we see that we have 2 on this side, so we will try and put a 2 here and check to make sure that everything is correct. So we have 2 sodiums, but now we have 2 chlorines on the left-hand side. So we can put a 2 here, and we now have 2 chlorines on the right-hand side. So as of right now, sodium is balanced, as is the chlorine. If we check, we have 1 sulfur, we have 4 oxygens on each side, so those are both balanced. The last thing we should check is the hydrogens, and there are 2 on each side. So we now have our balanced chemical equation, where we have solid table salt reacting with sulfuric acid, which forms sodium sulfate, and hydrochloric gas. So in terms of a experimental observation, well, we know we form sodium sulfate, we form HCl gas. This HCl gas is actually going to indicate to you, and it's going to indicate to you the experimental observation. So you're actually going to see a gas evolve. And HCl gas is also colorless, just like CO2. And HCl gas actually has a stinging odor. So this is going to be a colorless gas evolved with a stinging odor. Now, if we move on to question number 5, we're still completing and writing balanced chemical equations. We're still predicting products, and we're still predicting experimental observations. So, for question number 5, we have aqueous solutions of table salt and silver nitrate. So, table salt, we know that it is NaCl, and it has an aqueous phase. And if we look, silver nitrate, we know has a formula AgNO3, and it too is in the aqueous phase. So, if we go through and predict our products, again, we have our cations, we have our anions, and we can crisscross them in order to predict what our products are going to be. So, if I take sodium and compare it to the anion in silver nitrate. Now again, writing down what the charge is for each of these species is going to be important. It's going to help you when you predict your products. So for sodium chloride, the overall charge of the molecule is equal to 0. You know sodium has a +1 charge, chlorine has a -1 charge. For silver nitrate, we know that the polyatomic ion nitrate has a -1 charge. And in order for the overall charge to be equal to 0, we know that silver has to be and have a +1 charge. So we have a +1, -1 charge for each of the cations and anions here. So if we crisscross, we have sodium +1, and we are comparing it to nitrate, which has a -1. So we cross our numbers to get our new subscripts, and this becomes Na+, or Na1 and NO3, 1. So we know this then becomes NaNO3, so sodium nitrate. So we've now predicted one of our products. And if we look at our solubility rules, we see that this is an aqueous compound. It will dissociate in water. So we have one of our compounds done. Now we need to predict the second product. So we have our cation number 2, silver, and it is going to be compared with our anion number 1. So we have silver +1, we have chlorine -1. We know that when we cross these, we get Ag1Cl1, which becomes AgCl. So we have our second product forming. Now, the solubility of silver chloride in this instance, if we look at our solubility rules, is actually a solid. So we have a solid AgCl forming. So we have predicted our products, and the last thing that we need to do is balance our chemical reaction. And if we go through and check, we see that everything is balanced on the left-hand side as it is on the right-hand side. So we have our balanced chemical equation with the appropriate phases for all reactants and products. So with our products, we know we have silver chloride, we know we have sodium nitrate in the aqueous phase, and in terms of our experimental observations, what we can expect to see is because this is a solid, we know that it's going to fall out of solution as a precipitate. So we can expect to see a precipitate, and remember this is my abbreviation for precipitate, of AgCl. In fact, this precipitate is actually white.